Okay, the identities that we're going to work on today is converting the product of two angles, trig ratio of two angles, into the sum of the two angles, the ratio of the two angles. And these identities are very, very useful when you come to integration later on. And then when you get your head around integration or anti-differentiation, you will understand why we focus on those type of identities, or why we've learned the trig identities before we actually start differentiation and integration. So it's good to do some practice now. So basically, any product, like for example 2 sine A cosine B, can be written as sine A plus B plus sine A minus B. Now, to prove those identities, you can do them as an exercise. They're quite straightforward. You just use the right hand side, open up the right hand side, and then you will see you'll end up with the left hand side. Another one is 2 cosine A sine B is the same as sine A plus B minus sine A minus B. Another one, when you have 2 cosine A cosine B, is the same as cosine A plus B plus cosine A minus B. So this is if you have product and you want to convert it to plus. 2 sine A sine B is equal cosine A minus B minus cosine A plus B. Okay, so they are quite useful when we open up expanding expressions, products or angles in here. So this is if you have product converted to plus. So you have A and B separate and you want to join them together for a sign. But then the other one of these, which is exactly the same, but using the same type of identities but written in a different format, when you convert sums to product. So this one here, we're converting product to sum. Just writing it here, product to sum. So the next identities we're going to work on is changing now sums to products. So we change sum to products. So for example, the first identity is if you have sine A plus sine B. So sine A plus sine B is the same as 2 sine A plus B over 2 cosine A minus B over 2. So that's the first identities. They are all these identities on your formula sheet. You just need to have always the formula sheet handy, so you can figure out which identity to use. Now, if we have the difference, again it's 2, but this time instead of sine, then cosine, now we will have the cosine, then sine. So we have the cosine A plus B over 2, and then sine A minus B over 2. Now, if we have the cosine, so we've got cosine A plus cosine B, it gives me 2 cosine A plus B over 2 cosine A plus, A minus B over 2. Now, this one is slightly different. It's cosine A minus cosine B. The first difference is sine sine. So we have sine sine, not cosine cosine. So we'll have 2 sine A plus B over 2. And this one is also sine. The difference here, not A minus B, it's B minus A, which is the only one different between the three. And those are all these trig identities that is very, very useful to convert from sum to product and they are very useful when you're trying to simplify, especially in fractions format. So it's always when in fraction formats you're trying to convert from sum to product, so you can simplify those common factors. So keep that in mind. Okay, we're gonna use an example. We're gonna solve an example that to prove a trig identity using the trig ratios, the sums to product identities that we've just explained in this video. Okay, so you can see the left hand side has two terms in the numerator, two terms in the denominator. You can't simplify it any further. And then on the right hand side has 2 tan 2x, which is again you can't expand it. So if we go to the left hand side, we can't simplify the fraction if we have minus or plus in between the terms in the numerator or denominator, but we can simplify factors. So that's why converting the numerator into multiplication of trig ratios and converting the denominator into multiplication of trig ratios will help us simplifying it. When you're solving trig ratios, is very important. When you're solving proving identities or anything to do with identities, it's very important to have your formula sheet in front of you, because that will help you to figure out which formula you're going to use. So looking at the formulas or the identities that you will you have to convert from sums to product, if we have cosine, difference between two cosines is equal to sine and sine. So I'm just gonna write that to sine, well, x plus 3x over 2, so it's 4x over 2, so that gives me the 2x in here, minus x minus 3x minus x. Okay, 3x minus x is 2x divided by 2 is x, so that's not minus, sine. Why did I write minus? Thinking and solving it. Sine x over. Now the bottom one, we will use the first identity, which is sine 3x minus sine x. So the difference between two sines equal 2 cosine sine. So I'll have 2 cosine, again 3x plus x divided by 2 is 2x, and then sine x. Simplifying the terms, you end up with sine 2x over cosine 2x, and that's equal to tan 2x, which is proven. So sine A plus 2B plus sine A over cosine A plus 2B minus cosine A equal negative cot B. So obviously you've got the two, remember when we have a fractions with two terms on the top, two terms on the bottom, to simplify that fractions into one term, because we don't have a denominator, it's the best is to use the sums to products, because when you have fractions you can simplify in the common product. So I'm going to use the top. In the top, slightly different in here, look, you've got three angles, looks like three angles, but you just treat them as the same. So sine plus sine, so I'm going to use the first one. So sine, just use different color, sine, this one is A plus 2B, that's your first angle, plus A over 2. Then that's 2 in here, I've missed it, cosine. Now we have A, which is that one, A plus 2B, that's all your first angle, minus the second angle, which is the A over 2. Now the cosine minus cosine, it's 2 sine. The first angle is A plus 2B plus A over 2. Then sine, remember that one is reversed, so we will have A minus a minus 2b over 2. Okay, now we try and simplify 2. Okay, well, I'm gonna simplify the 2 so that 2, this 2 with 2, this 2 will simplify, so I don't have to rewrite it. And then now I have sine a plus a is 2a, so it's 2a plus 2b, and over 2, so that's really a plus b. And then cosine 2b, 2b over 2, so it's b over. This one here again, it's sine a over a plus b over, sorry, not over 2, because we divided by 2 already. And this one is sine negative b. Cancel out common factors in here. Equal. Now sine negative b is the same as negative sine b. This is about even and odd functions. We can explain it later, or you can search it why. So cosine b over negative sine b. Cosine b over sine b is cot b, so that's why you'll end up with cot b, and that's proven. These are, sine negative b is the same as negative sine b. These type of things are quite important actually. So just search it odd and even numbers, odd and even functions for sine and cosine. You can just do a small Google search, will explain it to you. If you need more help, you can just let me know. Thank you.